Thank you, Phil, and good morning, everybody. So I'm going to give a talk on a work carried out in France between 2010 and 2013 to evaluate the environmental impact of agricultural products, including carrots, of course, for today, and a few other fruit and vegetables. So this work followed the initiative of the French Ministry of Ecology in 2010, which planned to introduce a mandatory environmental labeling for consumer products and to use life cycle assessment to support this project. And because of the lack of life cycle assessment studies on French agricultural products, a research program called Analyse has been launched by EDEM, which is the French Environment and Energy Management Agency, to develop a public life cycle inventories database for agricultural products with two main objectives. First, to provide data for a future environmental labeling of food products, and second, to help people working in agriculture to analyze production chains in order to reduce their environmental impact. This program, Analyse, was managed by a consortium of 14 partners, ADEM, with 3 research institutes, INRA, CIRAD in France, and Agroscope in Switzerland, with some of the best specialists of life cycle assessment in Europe, and 10 technical institutes representing all agricultural productions, including the CTIFL for fruit and vegetable industry. This 3-year program produces life cycle inventories for about 40 French products based on the most representative production systems. It was the case, for example, for carrot, tomato, potato, apple, peach, grapes, arable crops, animal products, and several tropical products like mango, clementine, coffee, rice, and so on. So, life cycle assessment was identified as the most appropriate multi-criteria method to quantify the environmental performances of production systems. Life cycle assessment is a standardized methodology, and its procedures are part of the ISO 14000 environmental management standards. And for these reasons, life cycle assessment methodology has been chosen by different countries in the world and by the European Union to assess and communicate the environmental footprint of products to make consumers and industrials aware of their environmental impacts. So for the work on carrot, the CTIFL and the Carrot Grower Association decided to study the French average production according to the main growing system used in the 2 major production areas, Aquitaine in the southwest of France and Basse-Normandie in northwest part, which represent about 60% of total production of carrot in France. In these 2 regions, growers and technicians participated in the design of most representative carrot production systems, and 9 different growing systems have been studied. In agreement with the Analyse method, the system boundaries were set from cradle to farm gate. That means that post-harvest operations, such as washing, packaging, storage, transport, and so on, are excluded. So we just focused on carrot production. To perform life cycle assessment, a detailed inventory of all resources used and all chemicals emitted must be drawn up. This phase indicates the amount of inputs used per functional unit, in our case 1 kilo of carrots, and also assesses the amount of chemical substances emitted in each environmental unit, air, water, and soil. For carrot, inventory flows include the production of seeds, energy for irrigation and mechanization, volume of water for irrigation, the production of plastic covers, if necessary, the production of pesticides, fertilizers, and machinery. And direct field emissions due to the use of fertilizers and the use of pesticides are evaluated using different models. For example, for nitrous oxide, phosphorus, trace metals, and etc. Of course, all field operations have been described for the 9 studied systems according to expert knowledge. And the kind of machinery used, the service life of machines, work output, diesel consumption have been described. And these field operations differ according to production areas, to the period of crops, the surface areas, the type of soil, previous crop, and so on. Another table to show the yields of the 9 cropping systems studied, which vary from 56 to 85 tons per hectare. Diesel and diesel per hectare used for field operation, which vary strongly by a factor of 3. And all the inputs are listed, such as seeds, fertilizer, etc. And here is an overview of indicators and methods used to evaluate the impacts. For example, on the first line, for greenhouse gas emissions, you can see the flux concern, carbon dioxide, nitrous oxide, methane, and the method used to quantify greenhouse gas emission, in that case IPCC1, and the unit, kilogram of CO2 equivalent. And you can see the same for other indicators. Now, what about the results? I will present a few graphs to give you an idea of the kind of results produced by life cycle assessment. And the first graph presents the contribution analysis of 1 kilo of average French carrot at farm gate. It shows the contribution in percentage of different inputs, mechanization in black, production of pesticides in red, electricity for irrigation in blue. I just have a look to see that the color are the good one. For the different impact categories, the climate change, ozone depletion, acidification, eutrophication, and so on. And for example, if we have a look at the first bar on the left, which concerns climate change, you can observe that the main contributor is the use of nitrogen fertilizers by their production in dark green, as well as nitrous oxide field emissions in light green due to denitrification. The 2 other major contributors are mechanization with diesel consumption in black and pesticides production in red, and in particular soil disinfection products, which represents more than 90% of pesticides impact. If we take another example for fresh water and marine eutrophication, which are the, I don't know, 1, 2, 3, 4, the 4th and the 5th bar from the left, you can see that direct nitrogen and phosphorus emission are logically the main contributor. And the last example, with ionizing radiation, is strongly impacted by energy used for irrigation, because electricity in France is largely nuclear. However, for the same reason, this electricity presents very low greenhouse gas emissions. The second graph compares the non-renewable energy demand for the 9 cropping systems studied and the French average in black, expressed in megajoule per kilo of carrot. And we can observe a great variability according to irrigation practices in blue, to the dose of disinfection products in red, mechanization in gray. So the production of 1 kilo of average carrot needs around 1.2 megajoule of non-renewable energy. Here is a similar graph for climate change with greenhouse gas emissions, which vary from 45 grams of CO2 equivalent to 100 grams per kilo of carrot. Same thing. In dark green, we can see the greenhouse gas emission due to the production of fertilizers, and in light green, the emission due to the use of fertilizer with the production of nitrous oxide, depending on the time of application, the composition of fertilizers, and in one case, the use of manure to protect the crop from the wind. To compare carrot to other plant products, here is a graph with the greenhouse gas emissions for several agricultural products. So you can see, for example, greenhouse gas emission for apples, organic one and conventional, peaches and nectarines, non-heated tomatoes, and arable crops. And you can observe that fruit and vegetables are well positioned in comparison with arable crops. It is mainly due to higher yields. And carrot in orange presents the lower impact on climate change, and the results are also good for most of the other impact categories I didn't show today. In conclusion, with this presentation, I wanted to show you that life cycle assessment allows us to quantify environmental impacts of agricultural products and to identify practices that have the greatest negative impact and thus help growers to improve cultivation techniques. And we can see that efforts need to be focused primarily on soil disinfection, reduction of nitrogen supply, if possible, and mechanization, in particular, harvesting method. I would like to thank the Carrot Grower Association, Vincent Schibert and Céline Gentil, who are present today, and all the people who participated in providing the production inventories in Aquitaine and in Basse-Normandie. Thank you for your attention.
It sounds like you're going to specifically target something like nitrogen utilization as an area where hopefully in the future the resource use can be reduced for carrot. Is that right? Is this a life cycle assessment used to set some goals for future production systems?
Life cycle assessment just show us the major impacting practices. So we can see that, for example, the use of or the production of pesticides for soil disinfection present a great impact on several categories like climate change, like ecotoxicity, and so on. And so we just say to the carrot grower technicians and growers, we can say them, yes, you have to work on this aspect if you want to improve your environmental impact. So we do not suggest solution. We just point the problems. But life cycle assessment can also help by comparing different growing systems, of course, organic one, conventional, or different growing systems.
Emmanuel Jouffriot from AgroCampus here. I was wondering, you pointed some main problems with carrot production based on the life cycle assessment. I was wondering, compared to other open field vegetables, can you explain more about what is specific to carrot production, or what is mainly maybe common to other open field vegetables? Because you made a broader study, of course.
Yeah, we do not have a great experience with vegetable open field crops. Carrot was the first one. Potato was also studied, but by another institute, not CTIFR. But what we can say is that the impact is probably very linked to the yield of crops. The particularity of carotte production, and maybe other, I don't know, I'm not specialist of open field vegetable crops, is probably the soil disinfection. But as you can see on the last slide, we can see that carotte is well positioned for climate change, for example, but it's also true for other impact categories. So we plan to continue this work with ADEME and to work on around 10 other productions and a few vegetable crops in the near future. So I will have some answer to your question in a few years.
Do you plan to extend this study to the other part of the channel? I mean, from the field to the dish, and was it done for the other vegetables or products? Because your study is stopping at in the field.
Yeah. Yeah, it was the objective of the work, Analyse. We just focused on the crop production stage. And we didn't plan yet to go further with post-harvest and logistic, transport, and so on. Well, we have, of course, a few results with previous study carried out on carotte, for example, a few years ago in Sweden, which compare different production and distribution chain for carotte in Sweden. So they compare production in Italy, in Spain, in I don't remember where, with Swedish carotte, which includes all the life cycle of carrots. But for the moment, for the study Analyse, we stay on the crop production alone.